So
I have 3 different options. I don't know what you guys want. I can get Cholula, Tapatio, or Sriracha.
everybody vote in the chat. Vote in the chat. What should we? Tapatio. Oh, Tapatio is a strong winner right out of the gate. Carolina Reaper hot sauce. That would be dangerous. Oh my goodness. All right. While Galilee gets prepared, what is the best thing to put hot sauce on? Do you put it on chicken? Do you put it on chips? Do you put it on eggs or rice or steak or tacos? Everything, nothing. My boyfriend said that he puts it on fruit. I was like, I've never seen you do that. What are you talking about? But he was like, no, it's delicious. And I was like, okay. So then we had to try it. It was awesome. So started celebrating National Hot Sauce Day already. Exciting. Actually, you also put it on fruit. That's exciting. Tacos and fruit. Yes, excellent. Excellent, excellent. So fun facts. Mexico, Central America, and South America have been cooking with chili peppers for like 6,000 years. So they've had the chili pepper plant for a long time. And then the plant was carried to Europe and Africa and Asia by mostly Spanish and Portuguese like explorers. And so then they brought it back to the other places, and now everybody uses chilies, which is cool. And then Tabasco is the longest living brand of hot sauce. But the consensus in my earlier class was that Tabasco is terrible. So I hear that. All right, Galilee, are you ready to celebrate National Hot Sauce Day? Wow, guys, check that out. Can everyone see Galilee? Pin that video if you need to. Wow, down the hatch. Ooh. Excellent. Yes, round of applause, round of applause. Amazing. Wow, just the things that you see in pre-calculus class. You don't expect to celebrate National Hot Sauce Day that way, but it happens. Yes, claps. All right. Araceli, you put it on burritos? Yum. Ah, this is making me hungry already. All right, team. Excellent. We're gonna jump in. Jumping in. So we have a Desmos today, a different kind of Desmos though. So I am excited. Hopefully you should still have paper. This is for Algebra 2. These numbers about submissions are for Algebra 2, but this graphic right here is for you guys, or like is true for you guys, which is that right now in the gradebook, you only have assignment 11, assignment 12, and the election math assignment. Those 3 assignments are currently making up 30% of your grade. So if any of them is outstanding, like if you haven't turned one in, or if you got a bad grade on one of them, feel free to resubmit, but they'll make your grades like skyrocket really fast because they are currently worth 30% because they're worth like the whole portion for semester 2. So if you're missing anything, please do make sure to turn it in. Most of you guys are in a great place, so that doesn't apply to you. We are going to jump into a Desmos today in order to learn our topic. So I'm going to go ahead and put it here in the chat. So some of you already logged onto it, so that is awesome. I'm going to stop sharing this screen so you have more easily able to head to the Desmos. I'm going to log on to the teacher side on my side. You're going to need a piece of paper for our warm-up, just like scratch paper to write something down. So if you need to gather that, go ahead. Let me grab mine. Awesome. I see 18 of us have made it in. That's great. Make sure everybody makes it in this morning. Yes. 1 second, Marley. There you go. All right. So I'm seeing many of us have logged in. You are jumping on to slide 1. Just let me know like how you're doing. Let me know how you're doing. All right, everybody should be on slide 1. I'm gonna go ahead and open up this version as well so I can screen share. All right, Cool. We're going to jump in. All right. So, 'tis a big day today. You can go ahead and drag your little robot to be sad, really sad if you want. You can drag him to be really happy if you want. You could be somewhere in the midst of sad to happy. And then if you want to just check in, say hey, let us know, or like let me know how you're doing. Get that out of the way there. Awesome. Ooh, some people got some Starbucks. That sounds good. Some people are feeling a little stressed. Some people are feeling less stressed than yesterday. It's almost Friday. Ooh, someone had an amazing breakfast. That sounds yummy. Someone singing the song from West Side Story. Pretty and witty and gay. I love that song. And some people are feeling neutral. Nice. Callie's feeling great after that shot of Tabasco. No, hot sauce tapatio. So I'm loving it. Excellent. Big fan. We have lots of green, lots of yellow, some reds. I appreciate you no matter where you're coming from. So thank you for letting me know how you're doing today. Go ahead and click onto slide 2 by pressing the next button. You're going to see a polynomial that is a cubic polynomial. You're going to go ahead and factor it, which means put it into its parenthesis version. And then once it's in its parenthesis version, you're going to type it in right here. You can go ahead and do that. I see Mia's got an answer. Maritza's got an answer. Emma, go ahead and break down the x squared minus 1. Keep going. You should be able to break it down a little bit further. Nice. Looking good. When you're ready, when you've completed factoring, you can move to step 3 to check your answer. When you've got it in factored form, you've got x plus something or x minus something, you can move to page 3 when you're ready. You're going to put that factored form right here. Great job, team. Seeing a lot of similar answers. All right, so I know that I'm gonna, I'm actually gonna do this on this next page. So I'm gonna break down this first part since I see that there are 4 terms. I'm gonna break it down into the first set and the second set. So if I was going to find the GCF of this, it'd be x squared. And I'd be left with x plus 2. Ignore that blue line. And then I'm going to go ahead and take the GCF out of this second set, which would be -1. Nothing else I can take out. -1 like that. And I'd have x plus 2, just like so. I can see x plus 2 is in common, so that's my true GCF here. And I know that x squared minus 1, x squared minus 1, like that would be what's left over from this part and this part. X squared is important there. So I can see that red line now matches up with my dotted line. However, I have not factored it completely. I've not factored it completely. Can someone come off mute and talk to me about how I could continue to factor this? I see lots of correct answers. Can someone come off mute and talk to me?
Squared with -1.
Wait, tell me more, Brandon.
X squared -1. You
Uh-huh.
could yeah.
What can I do with it?
Oh, you could what do you call it? You could I forgot what the term was called, but you could
That's
like
okay.
split it up.
Uh-huh. I can split it up into what?
X -1
Mm-hmm.
and X plus 1.
X minus 1 and X plus 1. Yeah, absolutely. I'm going to take
Okay.
away this guy here. Thank you, Brandon. And so now I have that same curve, right? I can see that this is the same curve, so I know that I did it correctly. I don't need this extra step here. Nice. Seeing lots of similar answers in slide 3, which is great. So you can go ahead and put your answer there. Thanks, Brandon, for helping me out. I will send you some there. Cool. We're going to jump into slide 4. So slide 4 says the factored version of this function was x plus 2, x plus 1, and x minus 1. What do you notice about the orange points and the factored form? You're going to go ahead and write your answer here. What do you notice about the orange points in particular and the factored form? Eric, can you come off? I really like your answer. Could you come off mute and just tell us what you were thinking here? Eric.
Oh yeah, sorry, I forgot I was on mute. Yeah, I just noticed that all the orange points were the x-intercept.
Yeah, all the orange points are the x-intercepts for sure. Super concise. And then Fatima, can you also talk to us about what you noticed?
So I noticed I did the opposite. So like where the x plus 2 is x minus 2, what equals -2. You get me? Like,
Uh-huh. Yeah. So you're saying like I see x plus 2 here, x plus 2, but then it's actually a -2 over here. That's what you're saying?
yeah.
Nice. Yeah, for sure, for sure. All the points are with the x sign. For sure. They're all on the x-axis, right? So these points here, so opposite of this, -2, opposite of this, -1, opposite of this, +1. Those are the opposite of what they are, for sure. Go ahead and click onto slide 5. So as you can see, and as we just spoke through there, the polynomial shows its factored form in its solution, and the factors have the opposite signs of the solution. Right, so solution x equals -3, the factored version is x plus 3. So go ahead and type on page 6, or I'm sorry, on page 5, what would be the factored version for x equals -1, and what would be the factored form, the factored version for x equals 2. Nice. Miriam, can you talk to us about your 2 answers for these factors?
So basically I put them opposite. So like if that's a -1, it's x plus 1, and x equals 2 is positive, so it's x minus 2.
Yeah, absolutely. Those are perfect. Seeing a lot of solid answers there. Thank you, Miriam. All right, let's jump in. Go ahead and check out slide 6. Slide 6. I'm going to go ahead and send you into some breakout rooms so you guys can work on this. Or well, I'm going to open up the breakout rooms. You can go to them if you wish. I'll close them again in a few minutes. But you are working through page 6. Working through page 6. If you finish early, you can continue on past page 6. Your breakout room should be open now. You can head into them if you want. You can stay here if you want as well. So if you're here with me and you're looking for a little direction, I might start by moving all the graphs together and then moving all the factored forms together. This is just like kind of how I get organized. And then moving all the answers together. All right. Can't quite see all my graphs. There we go. All right, so it says match each graph with their solutions and their factored form. So each pile should have 3 cards, 1 graph, 1 number, 1 solution, and 1 function. So let's just start with this one. This one I can see I have a solution at -1, a solution at 2, and a solution at 4. So I'm gonna look for the answer that has -1, 2, and 4. So -1, 2, and 4 is here. And then I know that they're going to be the opposite for their factors. So it would be x plus 1, x minus 2, x minus 4. So x plus 1 minus 2 minus 4. Yeah, I can do this one here. And that would be how I match the first set. And then I can go ahead and close it by closing here. Right, so I know that one's done. So now I can move on to a new graph. Let me know if you have any questions. All right, team. Welcome back. Hope that your breakout rooms were productive. Wanted to show you just how I went about matching them. So you might see -3, -1, and 2 are your solutions, right? The places where they hit the x-axis. So I'd find the one that says -3, -1, and 2. So it'd be this one here. Go ahead and drag that. And then I know that they are opposites in their factors. So it'd be positive x plus 3, x plus 1, and x minus 2. So that would be this one here. So I'd go ahead and match those together. And then I go ahead and say, okay, I'm going to close that and move it away. And then I'll start with a new graph. Something to be mindful of here, you have -1 and +1. So -1 and +1 goes here, -1, +1, and these last ones must go together, right? Cool. Sweet. So you might have noticed something funky if you had to page 7. You might have noticed something funky as you were looking at those graphs. They don't all look like really fancy, nice looking graphs, right? So on page 7, you are talking about what did you notice that was funky? Anything you noticed? One said it does look funky. It touches the axis 3 times for sure. Mia is noticing that the y-axis goes up by 10. I think it goes up and down a lot for sure. Different compared to other problems that we've done. The graph looks super bumpy. It's going up and down multiple times, definitely. I noticed that this graph has multiple parabolas. Yeah, it has a parabolic shape here and also there, for sure. This graph is a 1, 2, 3, 4, 5, 6. This is x to the 6th power. X to the 6th power. I love this answer. Brandon says on point -1, so where x equals -1, it almost seems like it's touching the x-axis for a long time. Yeah, it like does this like flattening out thing. It looks like it touches the x-axis for a while. It's still only touching at -1, but it looks like it's very close to -1. Right, so I see different kinds of things here. Something I noticed is that I've never really noticed this before, but on this particular graph, every time it touches the x-axis, it kind of touches it in a different way. So for right here, it just goes like straight through that point. For at -1, it like flattens out, like Brandon was talking about, and gets really close to it. Does this like flattened out thing. And then at x equals 2, it comes down and hits it, but then it bounces back up. Right, so 3 different ways that it can be a solution, or like what it can look like when it's going to be that solution there. Pretty cool. All right, the next few slides are going to be a little bit more like informational slides, kind of like lecture slides, so we can see them. So on page 8, you will see what I was talking about when I said like it was going to hit that point and then bounce back up. This is called a double root. So what you're seeing at x equals 4 is called a double root. In the equation, it's represented by the exponent 2. So you may have noticed that there was an exponent 2 in some of your answers on the card sort, and that's because that is what is representing a double root. That's how we make it bounce back up. It can also bounce below the x-axis, so it can come up to the x-axis and dive over. I'm going to go to slide 9. There are also such things as triple roots. So that root that Brandon was talking about, where it looks like it touches the x-axis for a long time, that is called a triple root. So what you see at x equals 4 here is called a triple root. It's represented by the exponent 3 in the equation, right? So if you see something to the power of 3, that means that you're going to see a triple root at that location. It looks like a mini cubic function, like x to the 3rd power. And it represents 3 solutions at the same point. So a double root is 2 solutions at the same point, triple root, 3 solutions. On slide 10, you'll see a vocab alert, a question to answer. It says, which of the following expressions have multiplicities? Which of the following expressions have multiplicities? So a multiplicity is any time that there is a double root or a triple root. Right, anytime that there is a double root or a triple root, you're going to select all of them that apply. All of them that apply. Anything that is a multiplicity. So multiplicity is anywhere that there's a double root. I can tell from those of us who have voted that we definitely think that the second one and the fourth one are. because they have that exponent 2. So x minus 3 in the first one, that would be a double root. And this one would be a triple root. There's actually one more answer. There are 3 correct answers here. 3 correct answers. See, some of us have found it. More of us have found it now. Yes. The third correct answer is the middle one. The third correct answer is the middle one here. And that's because x plus 2 has just been written in 2 times, right? It's been written there 2 times, but that still means that it's a double root because we could write this as x plus 2 squared, because x plus 2 times x plus 2, anything times itself, could be represented with a square there. So there are 3 correct answers here. Go ahead and go to slide 11. All right, these are our odd degrees. So I went ahead and graphed, this is this function here, and this is this function here. Notice there is a slight change in the second function. And then go ahead and write, what did you notice in this box down here? For sure, people are seeing the negative sign. That negative sign flips it over, right? So we see we have a positive direction here. It's headed in the positive direction. If it has that negative in front, it's headed in the negative direction, right? It flips the entire graph over for sure. And finish up your sentences there. Great job. When you're ready, you can move to slide 12. You can check out some odd graphs. All right, on slide 12, you'll see a bunch of odd graphs. You'll see in the first column, positive graphs. They head up over time. So this one, yes, it goes down a little bit here in the middle, but over time from left to right, it's headed in the upward direction if it's positive. Even this one where it's like doing a lot of up and down, in general, it's headed in the up direction from left to right, right? For your negative graphs, if they're odd and negative, they head down overall, right? So this one, yes, has a lot of things happening, but it's headed down overall, right? So your odd graphs start at the bottom and head to the top if they're positive, or they start at the top and head to the bottom if they're negative. So these are our odd graphs. This is like x to the 3rd, x to the 5th, x to the 7th, x to the 11th, x to the 101, right? Anything that has that large power. That odd power. Go ahead and go to slide 14. Did we skip? Yes, we did actually. Go to slide 13. So 13, you can go ahead and answer that question. What did you notice? It's going to be very, very similar to what you noticed on the last time. Yeah, the negative sign again flips these over, right? So if it is even, right? If it's even, it starts up and stays up, right? Starts up and goes up again. Or it starts down and it goes down at the end, right? So these are like your parabolas, your cortex, x squared, x to the 2nd power, x to the 4th power, x to the 6th power. These are your even degrees. If you click over to slide 14, you'll see your even graphs and what they can look like. So even positive, that would be like these graphs here in the first column. So this graph, it opens up like a cup. Like if you imagine I could pour water into this graph and the water would sit in the graph. It wouldn't run off, right? It's not a water slide, it's a cup, right? If you're looking at like this graph, like here, it has some other bumps as well, but ultimately it's up like a cup. This is a positive graph. Positive graphs here as well. Your negative graphs are down like a frown. Oh, I remember it. Down like a frown. So you'll notice they wouldn't hold water, but they kind of look like a mountain. And you can see the other ones. This one even more looks like a mountain, but they are facing down. These are your negative x to the 4th power. All right. I'm going to go ahead and have you guys take a look at, go ahead and take a look at slide 15. You're going to go ahead and quickly match. And quickly match your even degree positive. So like this one is an even degree positive, they would go together. Another set would be your odd degree positives. They're headed in the upward direction. Odd degree negative and your even degree negative. Go ahead and match those up. If you're having a hard time, you can check my screen. My screen has one example of each. Mia, David, Christine, you guys have done a great job. If you want to continue on, you are unlocked to continue on. Amaris, Melissa, Gallery, you guys can continue on at your leisure. Emma, great job. Move on. So remember, for your evens should be up like a cup or down like a frown. Your odds will be headed either in an upward direction or in a downward direction. So basically, if they do the dance like this, if they go like this, they go in different directions. I don't think it's like Michael Jackson. I can't remember. The dance that goes like this, those are your odds. And then your evens go up or down the same direction. Nice, good adjustments. When you're ready, go ahead and continue on. You can check out slide 16. All right. You're gonna see some challenges, and this is gonna, I'm gonna release you into the wild for your homework today. And I'll let you pop into your squads if you would like. You are gonna see some challenges. There are gonna be challenges like update this equation so that it goes through these green points, like potentially, okay, I see this is -1, so I'm gonna make this x plus 1, and now it goes through that green point. I also need it to go through +1, so I'm gonna do -1 like that. And I see, okay, it goes through that, but I also need it to go through here. So x, that'd be +3, so -3. Well, like that, right? So I've done it, I made it go through the green point. I did challenge 1 for you, woo, great. So challenge 1 is fairly straightforward. You'll see there are a variety of challenges. There are 12 challenges. You do not need to do all 12, right? Turn to someone in your house and just tell them you do not need to do all 12, or tell the air, because I have no one in my house. You're not going to do all 12. You're just going to do 6, right? So 6. If you want to do all 12, cool, extra credit, go for it, rock it out. I will never stop you from doing more math. But 6 of them are required. So I'll be looking for you to have successfully completed 6 challenges, 6 total. You can skip around. There are different types of challenges. So you can try sketching them on your own. You can try whichever ones you want, but you have to do 6 challenges. And then the last 2 pages, 29 is a summary and 30 is some feedback. Those 2 pages are mandatory. So I'll repeat again for those of you in the back. You're doing 6 challenges, 6 total challenges, and then slides 29 and 30. 6 challenges, 29 and 30. Put it in the chat. How many challenges are you doing? 6 challenges, yes. 6 challenges and then the last 2 slides. 6 challenges and the last 2 slides. If I do 12 challenges, I get a million extra awesome points. Yes, Axel, 6 plus the last 2. So 6 challenges. If you want some extra credit, you can do more challenges. If you're just having fun, go for it. I'm here for it. If you have a question about any of them, please let me know. I will have my office hours from 3:30 to 4 today, but I'm also available to message you via text message, via email, whatever you need to get you the help that you need. So just to summarize, for the rest of it, you're going to see a bunch of challenges. You're doing 6 of them and the last 2 pages. Okay. Are there any questions before we head out today? Any questions? Any questions? All right. At some point, you might see a little green thing pop up. That means that I've left you a comment. If you click on that green thing, you'll be able to see my comment. So go ahead and click that comment. If you see it pop up, you might not see it, but that is how I'll be able to interact with you inside of the Desmos link. Other than that, I can give you back these 90 seconds of your day. Go, be free, have an amazing day. I'll see you at 3:30 if you want some help, and I will see you next week. Bye, guys. Adios, amigos. Love you, love you. Bye, bye. Bye. Bye, Brandon. Bye, bye, bye. Adios, bye. Gali, the real hot sauce hero. Bye, Kayla. Bye. Bye, Mia. Bye. I always forget to stop recording. Bye, team.